I'm here to talk about contract testing, and I hope I'm going to make it easy. I learned the hard way back in the days that, well, the tests we were doing, if we are doing them, were not that easy to maintain. And not only that are not easy to maintain, they become a nightmare when it comes to deploying all the microservices and having confidence that your system is safe and sound to deploy in production to see the light of day. So that's why I said I'm going to focus a bit around contract testing to see how this can maybe improve your project. So let's see a bit of about me. My name is Irina. I'm from Romania. I work at Particular Software. I'm a colleague with Leila. I blog from time to time, and I'm passionate about everything that moves around .NET space. But sometimes I'm focusing more about either microservices, either gRPC, or libraries like in Service Bus and Strands. So I also written a book, which is interesting if you want to switch and learn APIs and do web development. So maybe you know someone that might find this useful. Okay, a short recap. We're talking about testing. And we're talking about testing in contexts where the teams are growing and where we have huge projects. The last project I worked on back in the days had 120 people, and it was an end user and consumer focused. It wasn't an internal project. And I noticed a lot of friction between teams that wasn't so nice to witness in terms of we had the microservice architecture. And we do microservices because all of those fancy terms that we hear. A microservice should be autonomous, should have its own database, yada, yada, yada. You know them already, right? So we realized that as soon as the teams started to add up and we started to develop more and more features, well, it wasn't so nice. We kept stumbling upon each other's toes, and we realized that from time to time things happen in terms of deploying to production. A team releases a feature that is not compatible anymore with some other teams, or it consumes something from whatever team is developing, and we realize that what we wanted and what we got back when we call those other APIs didn't match anymore. So we had to find a way around it. So this is what I'm gonna try and preach today. So a short recap about unit testing. I'm just curious if you're doing unit tests and if you find them useful, because during the time I realized it's super nice to do unit tests and I advise you to do them, but it only focuses on business logic, testing small chunks of apps in isolations. I like them that they are very fast, and this is what we want to have fast tests so we can run them whenever we want to on local machine, on your colleague machine, and so on, right? So unit testing should be repeatable, consistent, and done in memory without touching other systems. So we're focusing on small chunks. We're looking at those and we're testing it that, hey, do this sum pass these parameters, then you should expect this as a result. And if everything is fine, the test is passing, and so on. So these should be not only repeatable but fast. And how fast they are depends on how much business logic we have. Actually, when we talk about unit testing, we are checking on one single concern in the system, only one, not a majority, not how these systems work together or how we're calling different methods together. We're testing only one small chunk. So once we're done this, we said that, okay, we're interested in integration testing. We're interested that now that we have the business logic safe and sound, and we're able to reproduce the tests every single time we're deploying something or we push a change on GitHub, now we're interested to see more how our services work together. So if A calls service B, uh, this will test the entire flow. It won't be an isolation. So we're answering basically the question how modules work together and if they work together. With integration testing, the system will call that one component will call other components that it needs. It will take answers from their responses if we send messages and so on. Actually, this integration testing can test the entire flow. So let's say we have a service A, that's an ordering API that will call the product and will call inventorying and billing and so on. When you do an integration test to test that ordering API, we will have call HTTP requests usually across the entire dependency graph. Okay. With integration testing, the deal is that we invest time and feelings in there, but it won't catch system-wide errors because we're testing over mocks. It requires to have visibility over the other code. So we do not get to have that high-level overview over the system. It will uncover errors that might occur when we integrate with individual modules by calling the code, but pretty much that's it. So when you do integration testing, you need to look in the code and to see what you're calling and what you need to mock and stub. Okay. Further than that, if we really want to be thorough, we can have different kinds of testing. There are so many of them that you need to focus on each individual one because they are so specialized. System testing can test, for example, the ability of a system to recover from transient faults. System testing can focus over the security of a specific issue. We can do stress testing over that system, and we can also do performance testing. Well, I think you're seeing this in somewhere. This is a testing pyramid that is promoted in some books, and it's very important to see pretty much where we stand in terms of how stable and how mature is our testing approach in our system. So first, at the bottom of the pyramid, we have unit tests, and then we have integration or system tests. You'll see a different terminology depending on where you look. And on top of it, right at the top, is this that we call end-to-end testing. And when it comes to catching bugs and errors inside our systems, we're thinking about how fast we can catch them. So once we climb the pyramid, we're realizing that the tests are very slow. And once we get down, we realize that these are fast. But the actual amount of money that we can lose by not catching them is in reverse. So at the top of the pyramid, to catch bugs is very expensive. So once you have a bug in the UI, it's very expensive to fix. And on the other side, when you have unit test and a flow in your business logic and you have unit test, it's very easy and fast and cheap to catch. The idea is that there are a few challenges. Some people invest, or some teams invest very much in end-to-end tests. We use things like Selenium and Playwright and things like that to simulate the fact that this systems is used by a real user. We're simulating clicks, we're looking and digging by HTML IDs, we get values from there, and you pretty much test flows by simulating that there is an actual user there. But there are challenges there. So let's say we have this specific system. We have an ordering component that will do an HTTP synchronous request to a catalog to get the product. And that catalog will do some other requests to, I don't know, external components. Basically, in this entire flow, we will depend on all those other components to be up and respond in a timely manner to us, right? So in the ordering system, if the last component in the call chain is down, what will happen? All the response will be down. So we try pretty much to prevent this by writing tests, end-to-end tests. And this brings us to a state where we have this system where we use a browser and we do an automation on top of it to make sure that, hey, there is someone there that tries and simulates that everything gets fine, it gets an answer back, and so on. This takes gazillion minutes to run, usually, and not only that, it becomes flaky and hard to maintain. So end-to-end testing, as the last resort, becomes very expensive to us to write and maintain. We will have long build times because basically the point of automating something in the system is to get confidence that we can deploy. Okay? And if we have a lot of moving parts in microservices, we have to be confident that when we deploy the microservice A, we won't break any other component in the system, right? So we have to take care of the infrastructure. It's hard to debug. That happens with end-to-end testing. It's super hard to debug. Sometimes some end-to-end tests, not that they are written bad, but the system behaves like that because we're basically not testing what we should test. How do you manage those end-to-end tests? What is the team that owns them? As a microservice developing team, you should have autonomy over what you develop. But end-to-end tests, it doesn't fit your job description pretty much. And you end up throwing end-to-end tests somewhere to be maintained by I don't know whom. Basically, it's not my responsibility. I'm taking care of ordering API. I don't touch UI. Yuck. So someone needs to be there to write those tests and maintain and update them. So there's usually dedicated teams, or we pass the ball from each other to from our team to the other team and so on, just to make sure someone will maintain them, or we simply forget about them. Another thing with this test is that they're flaky. Flakiness is the thing that we are mocking and stubbing. We are not testing against real components. And in test, it works. But in production, with a different connection string, we might get the wrong endpoint. What happens is that we get a false positive, or that our test is not reliable, because in production, we don't have the same connection strings, the same databases. Um, the environment is different, basically, right? So I've seen a number of problems here. Uh, these tests become either free for all the team are granted access. Not all the teams have the competency of knowing what's in there. We run and we implemented and we adopted this architecture, microservices, because we wanted autonomy from other teams. We were now able to deploy independently and we did the things ourselves. We didn't care about any other teams. We didn't want to communicate with others. We simply focused on what we have to deliver and that's it. But when these tests break, everyone assumes that is someone else's problem. So they do not care, and they either disable this feature of testing this specific issue in product in the CI/CD pipelines, or that's it. Or how do we maintain mocks? Or as soon as the team is starting to grow, we get slow feedbacks. In a team that has 100 people split into different capabilities that commit things and they develop features and they commit code, and that code gets into the pipelines and it's tested, the test suite is run there. It's super, super slow to see what happened if a build failed. Who is the team that caused the build to fail? Why is the reason? What should we do to address that fail? And so on. So it basically raises the issue of team ownership. Who owns this? It's something that hangs out in there. We need them because we want to build trust. But when it comes about team ownership, um, things are not that nice. Okay. So with end-to-end testing, we kind of lack this feature independent testability. And indeed, they do help pick up semantic breakages. If the contract from a API that we're calling breaks, we will later than sooner, we will pick up that semantic breakages. Okay, but basically, the larger the scope of deployment, the higher risk of failure, right? And there is a research summarized in a book called Accelerate, where these changes caused by end-to-end testing can be managed with a small number of services. But when this grows and the number of team grows, our ability to independently deploy a microservice as the team uh, will require a test suite that is shared by several teams. Because even though autonomy, it is what we want to propagate, we won't get that. Because now our small chunk that goes in production, it's not going to be independent in production. It will talk, it will do requests with some other features that are developed by other teams. And they too need to be aware that something had changed. So they say that high performing teams were most likely to do their testing on demand without necessarily requiring an integrated test environment. So, what we're doing when we write such tests is that we're stitching back our microservices just for testing purposes. Exactly what we're doing. So, in a microservice system, the capabilities we expose via user interfaces or APIs that are consumed are delivered by a number of microservices. That's why we have backend, front end for backends, and so on, or backend for front ends, pretty much. We have a front end application that consumes several microservices, several APIs behind the scenes. Okay, so if we do not want to break things, we need to deploy microservices together just to make sure that if we are in version 3 of a specific API, we must have sort of a snapshot of the entire system. But we don't want to do that because we're back to monoliths and we just run away from it to move to microservices. So basically, this naive approach of testing all together won't work. So what if we could have the fastness of an unit test, but test the integration points? So what if we could have a reduced scope? We could test in isolation, but still pick up semantic breakages. And I need to pause for a bit and explain what is semantic breakage. A semantic breakage you'll find in Sam Neuma's book, explained very well with almost an entire chapter there, is that if you, as a service, you're consuming another service, and at a point in time, you have this expectation. You expect this specific fields to get back as a response, and that service you're calling changes and removes some fields or adds or changes data types, that will be a semantic breakage. Okay? So basically, you need to catch them because in microservice architectures, pieces are moving. And when things are moving, they're most likely to change. And you need to capture those changes. And this is exactly what consumer, where CDC sits in the middle. Okay, so fast tests, they run super fast, and it will allow us to have exactly this build pipeline that is super slow changed. With now on build in CI/CD, we have unit tests, then we run integration tests, and then end-to-end takes a million years. Okay, we will change this approach. So with consumer-driven testing, we would prioritize the need of the consumer. So if I, as a service, I need to get data from another service, I would capture this specific need somewhere, and I would run tests against it. So basically, I would have expectations for how my provider should behave. So if I consume the other service. The other service will know what I need. So my priorities um, will be communicated pretty much. So what helps us to do is to catch accidental breaking changes early. And how early it is? During development time. So CDCs are basically expectation for how pretty much the consumer microservice should behave. So we would only need to run uh, these tests and put it against the provider, and we'll see how those are looking like. So arguably, consumer-driven contracts are more about fostering lines of communication and collaboration between microservices and the teams that consume them. Um, it handles breach of these contracts and catches bugs very earlier by, well, catching breaking changes, those semantic changes that I mentioned. So getting back to our schema, when we do end-to-end testing, we're basically interested in what happens if we click this button from the UI, let's say, all the flow that our request takes to get us favorable response or a response back. But what we're really interested in is the integration points that happen between these services, because we really want to deploy them independently. And we really want not to break the cold chain because we changed something. Okay. So actually, what happens with microservices and actually with entire teams is that you have a provider or a service, depending how we want to call it, and we would have consumers. Well, in some cases, we have only one consumers. We know who that consumer is. But in most of the cases, we have different consumers that we cannot control, and they have different expectations from us, the provider. So they call us to get responses with data. Okay. So as soon as the provider changes or the feature set changes, where we want to introduce a new version, do another release, and so on, we will realize that this feature set grows and some of our consumers might catch fire because we have a breach in the contract. So this is exactly what we're trying to prevent with consumer contracts. So let's rebalance the pyramid. Rebalancing the pyramid basically means that we have all these kinds of tests, and maybe we shouldn't invest so much time into writing them and maintaining them. So why write integration tests or end-to-end tests when we could do contract tests in between? So we end up with saving us some time to develop actual features because our pyramid now is smaller. And it is smaller because with introducing contract tests, we prevent bugs and we do not want to maintain flaky end-to-end tests. Okay? So how is this looking? Basically, we have a consumer and a provider. This is the terminology that we're using when it comes to consumer contract-driven testing. And we introduce something in between. The consumer would be a service, the provider would be another service in our case, if we're talking microservices. And in between, we're saying that we want to each part to honor its part of the contract. So in here, we would have our consumer saying, hey, I need this. And as soon as I need this, I have to publish this specification somewhere. I have a bunch of code to show you, so don't worry, you'll see it in practice. And then when you publish this contract by testing, on the other side, the provider will say, hey, consumer, what do you need from me? You need what's written in the contract. Okay, cool. And we run tests against it. And if we cannot honor the contract, our test will fail and we will notice that we have a semantic breakage. Okay. So what is this contract basically? The contract is an agreed interaction at a specific point in time. So if I'm today and I need to respond with this or I need to consume this, this is exactly what I'm going to write there. I'm going to say that I need to make a call to an orders API or to a products API, and I need these 4 fields back. I need a 200 OK as a response, and I need this JSON body to be present, and also maybe I need a custom header. I specify that on build and on test run. That will be generated as a JSON file by the consumer, but verified on the provider side. So now on the consumer side, we would have automated tests that test the interaction, but as a result, we will have this contract. And this contract will be the one telling the provider what it needs to give us. Okay? The provider part on the right-hand side, we will see that we have this contract. We take this contract, we run tests against them. The contract can have several lines, can have several operations. And we would see that, hey, what's in here, I am able to honor. If I'm not, I'm going to fail the test. But this way, I catch semantic breakages. And I will see how the provider behaves. So if we were to think about RESTful APIs, RESTful APIs and consumers, those were supposed to be developed and to evolve independently. If you evolve these two entities independently, they might not be able to communicate with each other at a specific point. We introduce breaking changes. Okay. I expect 4 fields, and now you're sending me only 2. I cannot do with it. So I might get an error when I call this API. So how do we test this? Well, we test this with something that is called Pact. Pact.io is a framework that has this library that we are able to use in order to test our APIs. So it allows our consumer to define its expected behavior from the provider. So you're telling it your needs, and the provider will test against your needs and see if it's able to respond or not. Okay, so consumer-driven testing tool. It was originally developed in-house by Real Estate in Australia. It's open source. Originally, it was for Ruby and focused only on HTTP protocols, but now it supports several languages and platforms, and also can be used for messaging, since the previous talk was about messaging. Okay, you have it here. Messaging interaction is very important to also test those, because the messages that are flowing in the system under the form of a command or an event, they carry data with fields, with things in there that can be changed. So there too, we can be interested in seeing these breakages. Using Pact. First, we're going to define the expectation of a producer, of the consumer. Then we're going to launch the Pact server, and we're going to test against this formal JSON specification that is there. We have language-specific SDKs. So if you're in JavaScript or you're mingling around with Node.js or so, you'll also be able to use this library Pact for that specific language. For C#, we have PactNet. And then we're able to use something that is closer to natural language to test. So let's see the code. I have here, you will have access to the code. So you'll be able to run it yourself. So do not worry. You have here, I'm going to show you the solution first. I try to split it more or less on the concepts that we're looking at. So we have the consumer side and the provider side. And in here, we're going to write things together. So on the consumer side, we have a simple console app that has absolutely nothing interesting. The consumer has a models folder, which mimics the models that we use with Web API or MVC. This is a product model. It has a few fields, decimal int string, nothing fancy. It's just to carry data. And then we have products API client that has some things already settled here. We're not going to use this. It's just here to show you that we can have different types of clients that we can use and write tests over them, those. API client is the same. It has an base URI, can call get all products. Basically, what I try to do here is to show you that you can either call something from your existing project, or you can create a test project where you can mock the client. So to have this specific test project, it's a small and easy XUnit test project, nothing fancy. I went there and I installed PactNet, PactNet abstractions, and PactNet output XUnit. And anything that is here is just standard XUnit project, nothing fancy. Of course, I added a reference to the consumer project that supposedly is the subject under test for our time being. And pretty much this is it. I also have here some plumbing that I had to do in order to allow us to write tests. So we have the client factory, which is an HTTP client factory that simply creates a client. And then we have the test setup, which is the interesting bit. So I'm going to try to explain it step by step, and then I'm going to try to show you how you can write tests. So we have this setup Pact is a test setup. It's a static class, nothing fancy. But basically what we have to do here is to say, hey, I have a Pact config where you have to store files. Remember that I told you that our consumers will say what are their expectations, and those expectations are outputted as JSON files. So what I'm doing here is to specify where are those pacts stored. And I did some fancy work. It's like how many levels up, and it's under this pacts folder, which you're going to find at the project level. You'll see here pacts. Everything will be generated in here as soon as we write some tests. After that, we're going to say the log level that we're interested is something similar to log information, debug, and so on, but this is in relation to Pact. And then we're saying which version we're using. We're using version 3. And then we're saying which is the consumer, which is the provider, and we pass in the configuration. And then we're saying that we want to test with HTTP interaction. All this with HTTP interactions. We can also have here messaging. So I'm going to, using native backends and with message interactions. Basically, this is how you're telling that which is the kind of contract that you want. So I'm going to Control Z and let it here. And getting back to here, we have two types of tests. I have a consumer and I have a product. Okay, this products bit will call into our provider, which is a products API, nothing fancy. It has some dummy data in there. It's a create, read, update, delete over a product. So we have get products, we have product by ID, fancy stuff. I'm going to comment this out. We have these cases if we do not have a product, we return not found. And if we find the product, we transform into a model and then we return it as a response. The put we're not using today, the post we're not using today. But feel free to try and get the source code and write it yourself. It's fairly easy to do so. And under the consumer pact, we will write our tests against this provider endpoint. So this is, I try to have two of them, one super simple and one with more closer to real life. So the provider will simply get a string and return different status codes depending on what we're passing here. So we're trying to pass a valid datetime. So we're going to look if what we're passing in there is null or empty. We're going to return this with a bad request. And if we're able to parse the datetime, then if we're not able, to parse the datetime, so the format is not correct, we're going to return this. And if, yay, we're able to parse it. We're going to return this test good and this specific parsed datetime. So we have only one method, only one endpoint. That's it. This is what we're going to try to test. Okay, so we're trying to say from the consumer's perspective that when I'm passing good data, I have to get back a specific status code and a specific response. So let's go ahead and do that. Okay, I'm going to close anything that is not related. Consumer pact, and we have this endpoint. Okay, this is what we're testing. This is what you're basically testing when you do end-to-end and integration tests. You have endpoints that you're trying to call somehow to make sure the entire flow works and you get back the response that you expect. Okay, so in order for me to progress faster here, I'm not gonna like type it step by step, but I'm gonna show you what we should do. So it parses date correctly, consumer pack tests. I'm gonna paste some code. I'm gonna explain it to you. Okay. In the consumer pack test, I need a test output helper that will spit out under this folder the result of this running test. And then we said I have a pack version 3 of the Pact with the name consumer provider. This is my name as a consumer, and this is his name as a provider. And I'm interested to pass in the config with HTTP interactions. So you have examples pretty much with everything you would need. Okay, then since I'm using XUnit, this is the annotated with fact, and it says it parses a date correctly. The expected string that I'm expecting is today date, right? And then we're gonna define what our expectations are. So we have this pact, and we're gonna say that upon receiving a valid GET request for date validation, this is your deal, this is your job to write whatever you see fit. Then you say, given that there is data passed with this specific request method, you can have either get or put or delete or verbs. It will call, I'm going to put the get back, the endpoint named API provider with the specific query string with this name valid datetime. And this is what I should expect back. And when this request is made, the provider will respond with the status code okay. It can be anything that you need to test, but now I'm testing the happy flow. It will also have the header of type content type with this value application JSON char set UTF-8 and with this JSON body. This is very helpful if you want to, if you have, for example, custom headers that you're using, custom MIME times that you're passing. Let's say you serve several consumers, each one with its own MIME type. You can test those there. And this will be the range. The act bit will be to actually call Pact, verify async the context, and then you actually do a call. And the call actually is by calling the API client static class, which you will find in the consumer bit, and you call a method from there. You pass the expected string and then look at the context, mock server URI to string. You assert that what you get is what you actually get. And you assert that date parse string, it's whatever you get from the response. Okay, if we open now the test explorer, you'll see that there is one single test here named it parses a date correctly. You right click and run. And we, fingers crossed, it's green. And you'll see some funky things written here. Tokyo runtime worker, Pact mock server, blah, blah, blah. Says that compares strings pretty much API provider with the body test good valid datetime. And let's see what happens. In the folder called Pacts that we configured at first, you'll see now a JSON opened, written. It's called consumer provider dash provider, which is exactly the name that I added here. Where are you? Consumer, provider, provider. This is the consumer side. This is the provider side, and it adds a dash between them. So if you open this up with Visual Studio Code, you'll see a JSON, nothing fancy, but this is a specification that Pact uses. For this consumer with the name consumer provider, very fancy name, it has this interaction. It has a provider state, which there is data. This is simply a string. You can add whatever you want there. It does a request with a get HTTP method to this provider path with this query and this data. And as a response, it expects back this specific body with this header, with the status code 200 OK. Nothing fancy here. We cannot do anything with it currently, but we can go ahead and write a provider test. So once we said, hey, provider, this is my expectation as a consumer, take your contract and test against it, we have to write some tests on the other side, on the provider side. So we open provider tests, and we would simply make a simple test. We annotate this too with the fact. We call it ensure APIs honors pact with consumer. I'm gonna pay some configuration things. Here too, you have to say this time that you have a pact verifier configuration that has an output helper as an output, and it has a specific log level. I think I wrote this. Okay. And then you have to say which is the path where our verifier passing in a config will find. So this is pretty much hard-coded currently, but you can read them from app settings or pass it dynamically. It's up to you. But basically, this is the JSON that I will look at from the provider's perspective. And then once I point it out to the right path, so don't be scared about this path join. You can use a different manner if you want, as long as you point it to the specific right file. And then we can say that, you know what, uh, we are the service provider. We have this name, we have this URI, and I want to verify with file source where I have this packed file. You can also have different verification bits. For example, we can have SSL verification disabled if we want to ignore that. We can have a packed broker. We will talk a bit about packed brokers and so on. But what we're currently doing is to look at the specific file that we just generated. So we take this and we test against it. So as soon as we did this, we should be able to see it in our test explorer as a new test. I'm going to maximize this a bit. You'll see that we have products API tests, provider tests, ensure API honors pact with consumer. Nothing fancy. There is a catch though. You would have to have the products API running if you want to test against it, because what Pact will do is to do actual requests towards it. So we will go here in our project. I'm going to see where I am. CD contract testing, CD products API, and I'm going to have it running. So .NET run. I'm going to wait. It will check some things that that are in there, and now you'll see that it's listening on this specific port. If you want to browse to the code, you'll notice that under the products API test, you'll see something that is called test fixture, where this test fixtures has this provider URI, which is the specific point of our product API running port, and then a Pact broker URI. This is standard. If I have time, I can show you how you can run in Docker Pact broker, but this will be the standard port. So this is where you will find it. And pretty much that's it. Now, when you run our tests, click run, you'll see that it fails, and see why it fails. The following constructor parameter did not have active fixture data, text fixture, fixture. Let's see, providers test. What did we do? Fixture. Fixture. It comes collection definition. This is very weird. Everything is in there. Let me put this. Apparently, I didn't pray to the demo gods. Let's see. I'm gonna stop this. Okay, output helper fixture. That fixture source come from the collection definition. Why do you complain? Text fixture. This is this. Okay, let's test this again. Otherwise, I'm gonna show you on the project where apparently did not have a text fixture. That's weird. Okay, let's see. Where am I? Let's test demo gods help. Close all tabs. Text fixture is here. This is here. Let me open the project. It's a good thing to have a backup project if things go sideways. And I'm going to open another tab. Browse to that. Okay, product API doesn't run. Okay, let's see. So this seems to be working. Waiting, it's there. View test explorer. Okay, we're here. Provider tests run. And now you'll see that it's passing. And you'll get back a result like this, verifying a pact between consumer, provider, and provider. And you see things like this, a valid GET request for date validation, given there is data, will return a response. I cannot do this, but I can do it with Zoom. Has a status code of 200, this is okay, will include headers of this time, has a matching body, okay, and so on. Also, I did some tests around what happens if I pass empty string for that date parameter. I would get back an application problem.json and a matching body that I have in there. Here too. So this is how you basically test the things that integrate. You're saying, hey, I expect this and I expect the provider to honor them. So if we look in our consumer text pact, you'll see random string as a parameter, how I did it. So I passed to the specific path. I said that I have a bad request. So this is what I'm expecting back, a bad request with content type, application JSON. And I'm verifying that if I'm passing a valid date to invalid date, I get the specific thing. And then what happens if I send an empty parameter, string empty, as a query parameter value, will respond with bad request and this content type and so on. If you want to expand that to match application problem plus JSON, you'll have to look at the JSON body too and to see what is the actual format to test it. This is for the, let's say, simple things. For the more complicated things, we'll look at the product's consumer tests, where here too, we're saying which is the pacts. We can specify things like serializers. Like we can say we want to have camel case serializer. If we want, we can have snake case. We can have any kind of serializers as long as we can specify in the contract what is the response that we're expecting. So if the API serializes data using snake case, of course, we should expect the response as snake case written, right? Okay, so let's see here. Should get all products. This is a scenario that we should look at. So get all products is a test that if we call using an HTTP GET this path from our products API, this will respond with the status code 200 of K, with the header having a content type application.json, and with a JSON that matches a list of a product model. Okay, so what we're doing is to say that we want to have a provider client factory that calls this, that has this mock server URI. We create a client. We act like we're calling the API products. We expect the response and we deserialize the response and then we assert some things. Of course, whatever you're doing in the verify async defines what you're actually testing. We're testing the status code and we expect that that product list not to be empty. But of course, you could look at, I don't know, the number, any things that are suitable for you. And this is how you define it. If we look at what our products API is responding with in the products, get all, simply we look at this. We expect a list of products. We mapped it and that's it. Okay. Let's test it. View, test, explorer. Where does it hide? And this time, under consumer test part, we look at the products consumer test and we said that we want all products to run. So we run it. You'll see pretty much not every single time. Most of the cases, all the tests from the consumer side are green because they are not tested against anything, but that's your input for verifying on the provider side. Again, funky things that uses strings, matching rules, paths, you see rule list, sends request to a specific port, and so on. And now, since I'm going to stop this, if I'm trying to run the test to verify that my contract, by the way, since I'm changing the folders, I should be able to also show a second Pact file, which is product consumer with the products provider discussion. This is open, so you can see all the interaction that this consumer does. Get responds with this specific type. It has this specific MIME type as the body. It has a few matching rules, and so on. Again, we're here when no matches are found and so on. But this is basically what you define. So when I'm calling this, using this, I expect this back. So this is what it tests. So let's run the product test, run, and see how it fails. And it should fail because our API is not running. So you have here the source that failed, Pact verification failed. It says, okay, I have these 3 tests, given product ID with ID 1 exists. I send a request for this specific path. It's trying to connect, but well, for nothing because the API is down and I don't have any response to act upon it. Same happens for the other ones that sends a value that shouldn't be there, and for the get all. So now if we run our project to have the API up and running, you see a lot of things happen. When we redo our ensure products API is safe and sound, we get a green passing test. So we're testing that it responds with the 200 OK, it has these headers, has a matching body, and so on. In case of a product that is not there, a product with 100 as an ID, it's not in the database, so it has a 404. It will include headers, application problem.json, because this is how I built it to be. It has a matching body or no body, and so on. Let's test something like, I want here and get product to have this header. I add a random header called culture, ENUS. Uh, I add here, it's important to me because maybe in the consumer side, they want to look at it. So if I want to look at this header or look after this header too, I will go in my products consumer test and I'm going to say, hey, get all products is not what I look about. This one. Okay, so get product. I want to call this endpoint. I want to get a response of this type, and I want to look at what I get back. I want to look, for example, a camel case naming. If I want to ignore null, you can also specify things related to serializer, so can be set there. But I also want to look at the culture header, EN-US. So if from the consumer side, I am expecting it, but on the provider side, I don't have it, guess what will happen with that test? It will fail. So get product, I'm going to run it. I'm going to stop the service because we have a build in progress. So run, get product should be able to be overridden there. And once we have this up and running again, okay, we would be able to run ensure products API. Okay, so we get something like this. Pact failure exception, verification is failed. It says why it fails. Culture width, value, like this, failed. So this is not found there because I commented out on the provider side. So now I have a failing test. So every single time a structural change happens, I am able to catch it by using this contract generated from the consumer. So it's really helpful because now I don't have to worry anymore that, maybe the other team changed the API that I'm calling, or maybe the type has changed and so on. I have ways of checking that what I expect to receive, I will receive. Or if I'm not gonna be able to receive it because things have changed, I'm gonna catch it as soon as possible in the development time. So you'll be able to see the code and run it by yourself. There is a thing that I also want to show you in terms of where do you store these contracts? Because it's easy, you have a folder locally, but when you're talking about the entire system and CI/CD, things are different. So there is this notion, this thing called Pact Broker, which is the CDC specific repository that can help you store Pact files. And since it has knowledge about consumers and providers, can also validate them. And it can also help you store different Pact file version, because that's the thing that we would want to version, right? So let's see how it looks. In the project, you will see something that is a Docker Compose. Let's see, Docker Compose YAML. So you'd be able to run Docker Compose app. And if everything goes smooth in the Docker, if you have it installed, where are you, Docker? Here, you'd see contract testing that has the Pact broker there and a Postgres database running. It needs it, so I had to provide it. So now, if we open that port that I mentioned with 9292, let's see, localhost 9292, you'll be able to see an interface that shows you a dummy example. Pretty much this is an API. So if you click on it, you'll see where repository is, which is the branch, and then you'll be able to also see the network graph. This will show you the integration between different APIs that you have. But currently, I didn't push our APIs there. I would do that with publish. There's a bad file that learning my fresh. I hope it finished. Yeah, yeah, yeah. I cleaned everything. So now when we refresh this, we should be able to see two more things. Our consumer provider and the provider for it, and the product consumer and the products provider for it. So you'd be able to see like the relationship between those. So if we click product consumer, again, the same information, it shows you what it consumes, what it needs. Of course, it's a very simple dependency, but it can be more complicated than that. We have here some options like view the Pact file. It will give you a pretty cool interaction based on that JSON file that is generated. Provider will respond with this, so it's easier to understand which and what response needs, or when no matches are found, um, product by ID will be here, stuff like that. 404 headers, like so it's simply a specification that this tool uses. What else? Also shows you when it's built, which is the provider, which is the branch, which is the what is the build version, and so on. You can filter them with tags and so on. It's very, very, very nice. Okay. What is the benefit of using CDC? Well, stubs are never stale. You will always, if you're using, you can integrate in CI/CD pipeline. You can test there. You can publish artifacts to your Pact brokers, or you can store it in your repo. The benefit is that you always know which is the latest version, and the stubs are never stale, so that in pre-production everything works like a charm, and in production the hell breaks loose. Okay, so this is one benefit that I really wanted to add here. Um, Basically, CDC is like TDD, but apply at the API level. Okay, and to summarize, don't test anymore your microservices as if they are monoliths. Don't tie them together. Back again, and start reducing your end-to-end test number and focus on what your consumer needs, because that's the integration points, and that is the thing that will help us catch bugs. Okay. Uh, Thanks for listening. I hope I gave you an overview of what CDCs are and how we can use them in order to uh, have better systems, pretty much.
Yeah, that was a really interesting talk. Thank you so
Yeah.
much for that. There's actually a lot of questions happening in chat around people's conceptualization of building APIs, integration testing, end-to-end testing. A common one that folks were asking was, does an open API do this for me? I am creating a contract. How is this potentially different than people just following my contract? I think you explained it well, but for folks who maybe weren't paying attention, could you summarize how you think this is different than that?
So basically, open API is indeed a specification, but that only shows you how your provider looks like, right?
Mhm,
If you're consuming that API, you have no way to tell that API, hey, I expect this from you. So
mhm,
pretty much CDC is moving the focus on the consumer, and it says, hey, I, as your consumer, I expect to have this. Take my expectation and do something with them. But Open API just announces, hey, this is what I can do,
mhm.
but it doesn't necessarily look at if it breaks or not. An API, Open API will change itself as soon as the API that has that will change, and that's it. It doesn't look at what others expect from you.
Yeah, I think that's a good point. It kind of flips the relationship. It's no longer a specification like
Hmm.
the name implies, it's contract testing. So there's a
Mhm, mhm,
contract and expectation for behavior, and now it's not the consumer's responsibility, it's the provider's
mhm,
responsibility
mhm,
to make sure that it accomplishes that contract, right?
mhm. And to
Uh,
mitigate the changes pretty much.
it's interesting because the thought, Martin, one of our colleagues, just wrote a GraphQL blog post. Folks should go check that out. It's a pretty cool blog post. But GraphQL keeps track of consumers and the fields that consumers are asking for in their queries. Do you feel like contract-based testing is still important if a protocol has that feature built in? Or can folks substitute a protocol like GraphQL in place of contract testing?
Hmm. I think there's a difference of nuance.
Mhm,
Basically, GraphQL will allow the consumers the flexibility of taking whatever that GraphQL endpoint exposes. It doesn't test anything. It's
mhm.
simply, here's what you can do. But on CDC is like, hey, I expect this from you. And as soon as you start integrating those tests in your pipelines, you'll notice that the hell doesn't break loose anymore when you move to different environments from QA to staging to user acceptance testings and so on. It really looks at everything around you and look, hey, a microservice changed. I need that to be as it was. Not gonna break. But GraphQL is simply for consumer side. You're not
Mhm.
testing anything with it. It's just here it is. I'm exposing this data. Take what you want from what I'm exposing. Yeah, so it gives the flexibility with GraphQL, and here it prevents breaking changes pretty much in
Yep,
all those small bits.
yep. Rachel, do you have a question?
Yeah, so there was one from the comments. Like, how is this different from BDD? Do you do any BDD stuff at all? And
Nope, I used to, but I don't. I don't remember exactly. 5 years ago, it was the last time I touched BDD. I don't remember it having this JSON that you can fly around and pass
right,
to the providers. It's simply it's similar in the sense that okay, you test what is the behavior that you're expecting, but it doesn't have that end goal of a generated thing that you can move across the pipeline.
yeah,
Mhm.
yep,
So, you showed kind of those JSON files that are like the contracts, right? The contracts that consumers and providers are expecting to be there. From a consumer's perspective, having those contracts, does it make it easier to test your applications? A lot of folks were mentioning end-to-end testing, integration testing. Do you still need those things if you're doing contract-based testing?
You need less end-to-end testing if you're doing contract testing.
Mhm.
That's a thing that I stand by. Because you in end-to-end testing, you don't have this speed as you get with contract testing. You want it now, and as soon as you introduce a change, you would want to see if it will break something without you worrying that I'm gonna leave it in the pipeline. Those end-to-end gazillion tests, unmaintained, flaky, not reliable, will run, and after 3 hours, maybe I would be able to see if I broke something or not. But
Yeah.
I want to see if I break something during the development time, right? So
Yeah, it sounds like you're talking from experience.
hard, hard learned lesson.
hard, yeah.
Rachel, are there any
Yeah,
other questions?
yeah, there is a few still. Yes, so
I
two of
can
them
go
kind of.
and address them if
No,
it's needed.
we have you here. You're here to
Yeah,
answer
yeah, you're
questions. Yeah,
here.
don't
You're
worry.
trapped for a little while still.
Yeah, I'm fine with that.
um, so do you feel like this kind of contract-based testing and formalizing the contract verification improves communication between teams? Which kind of
Super
harkens
smart
back
question.
to Lila's talk a little bit because it was
Yeah.
very heavy on communication and whatnot. So how would that play in here?
Basically, when you integrate this into a pipeline, you don't need to communicate. Things will break and that's it.
Oh, all right. Good until you said break. Okay.
But developers are so good at communicating with other people. Come
Yeah,
on.
you say
Imagine
so.
that. Yeah, so good.
No, I'm just some are, some aren't.
Yeah, yeah, but that's very cool. One of the things you showed, if you wanted to integrate contract-based testing into your current workflow, what are some places in your current workflow that you have to kind of reassess and potentially change to adopt this new style of testing?
Basically is in the pipeline, where is this small tool that they provide called Can I Deploy?
Mhm,
Uh,
Ah,
so it's a CLI tool that is very cute. That will allow you to say, okay, you can deploy because all the tests are passing, or you cannot deploy because
mhm.
something is. So it will prevent the actual deploy from happening.
Yeah,
Just
and
like a guard.
yeah, I mean, we saw in the previous talk the complexity and trying to manage and make sure that deployments and coupling are in a state where you understand where the system is. So a tool like
Yeah.
that sounds like an awesome feature that folks can
Mhm,
put
mhm,
in
mhm,
just to have that extra guardrail, like you mentioned, to kind of keep them from deploying a broken system. So
mhm,
that's pretty
mhm.
cool.
And
Um,
having to roll back because basically that's
um,
the most painful part.
Yeah, always roll forward. There's no going back,
Yeah,
people.
yeah.
No going back. So, Rachel, any last questions?
yes, kind of like a spin-off from that next one then. Especially if you don't need as much communication, right? Is contract testing for internal teams, or can you open it up to external parties too?
Very good one. It's not necessarily for no, rewind. You cannot use SIGDC for integration points with other providers, with external providers, because both parties have to agree on this contract. So if you're consuming, I don't know, since Cecil will be next, Stripe API, right? Stripe would have to agree to test on its own side so it doesn't break you. And that's not necessarily possible.
Mhm.
So for your microservices, your internal teams, yeah, that would work like a charm. But for the other things, there's still integration tests to do.
Yeah.
Because that's, yeah.
Yeah, on that note, I think that's all the questions. I really love this talk. Thank you so much
Right?
for doing it. I think, if there's anything, I think it gives people an opportunity to think about their current testing style, their internal communication within teams, and if they're thinking about breaking up a monolith into microservices. I
Mm,
think this talk is very enlightening for them.
one
So
thing to consider, yeah.
yeah, so thank you so much for this. On that note, we're gonna let you go. We really loved it. Again, we'd love to have you back, and thank you so much.
Thank you for having me.